Nice job, Max. Nice job, Abby Wasta. Thank you for that second one, Peyton. Nice job, Peyton. Okay, we are taking, nice job, Gabe. We're going to take 11 more seconds. Remembering that on remote days, every single person needs to be active in the chat because I have nobody here to interact with besides myself. So I need everybody to be super duper active, take an initiative and start to really be throwing those answers in. Awesome job, everybody. Let's take a look at this guy here. So if we look at description number 1, so my suggestion for this is to just read through the descriptions and try to make matches. So it says 2 divided by a number squared. So what do we have to do first in that description? First thing that we have to do is very good. We have to divide 2 by that number x. So which one did we match letter A to? Nice job. Very good. Nice job, Naseem. Nice job, Peyton. A matches with number 4. A matches with number 4 because we're dividing 2 by a number, and we represent that by using a variable. In this case, we're using the variable x. And then we need to square that number. Good. Now, next one. We're looking at B, a number plus 7, then multiply it by 2. If it's in, nice job, Junior. If we're saying a number plus 7, we're going outside of that order of operations. So what do we know it has to have in it when we look at it? What's our equation gonna have to have in it if we're going outside of that order of operations? It's gonna have parentheses. So B is going to match with, just like Naseem said, number 2. Very good, Naseem. Okay, now next, a number squared less 2. What does it mean when it says less 2? Good, Naseem. Yes, Abby Wasta. When it says less 2, that means minus 2. Exactly, Kyle Kelly. Exactly, Junior. So if we say that it's going to be less 2, subtract 2, a number squared, x squared less 2, matches with number 1. Then the last one, 1/3 a number plus 10. So 1/3 x, nice job, Naseem. It goes with number 3. That's supposed to be a D. It goes with number 3 because 1/3 a number means 1/3 times x, and then add 10. Awesome job, everybody, on that hard work. Everybody did so fantastic. Nice job, Max. Didn't get to acknowledge that before. Very good. Thank you, everybody, for being such active participants. Great, great, great job. Okay, so now what I want us to do is we're not going to keep moving with this. We're going to go back to the slideshow from yesterday. So you're going to go into the activity 3-2 task at school, and you're going to open up that slideshow. Okay, remember it looks like this, using function notation to describe rules, part 1. We're going to scroll. We already completed this slideshow up to slide number, we left off on slide number 9. In slide number 9, plotted points that we used when we were talking about the area of a square, right? We said it had a side length. If we look back and we look at these points here, we said side length of 1 had an area of 1, a side length of 2 had an area of 4, a side length of 4 had an area of 16, and a side length of 6 had an area of 36. What do we notice when we look at this equation line that we drew in here? Can I have, let's see, who can help me and who can unmute? What do we notice when we look at this equation line here on slide number 9? Let's see. Connor, can I have you on mute? Tell me, what do you notice? Anything at all?
The graph is proportional.
Okay. Good. The graph is proportional because it starts where?
At the origin.
Very good. Starts at the origin. Logical. Side length of 0, area of 0. Good. Max, what else do we notice when we look at this guy here? Unmute yourself, Max. Let me know. Go ahead. Max, are you there? No? Okay. If we look at at each of these like segments here that we drew, like this segment here, this segment here, this segment here, what do we notice here? I can't hear you. It's okay, Max. Can I have Gabe? Can you unmute and tell me, what do you notice also about this graph here?
It's not a straight line.
It's not a straight line. So we are going to be looking at, this is actually going to be called like an exponential graph, and it really connects to when a lot of people talk about when we're looking at the news and we're talking about lowering that curve, right, of that COVID. It looks like it curves up, and that's what this is the type of graph that's representing a similar type of display on a graph. You're going to not have a straight linear line. We don't have the same rate of change every single time. Each of these segments sort of has its own rate of change, and it's going to look sort of, if you were to continue this on, it would look sort of curved, okay? And that's going to be called an exponential graph, and we're going to be talking about that in a little bit at next unit, actually. Very good, nice job. So if we move on to 10, okay, a roll of paper that is 3 feet wide, so it's always going to be 3 feet wide, can be cut to any length. So we have a big old roll of paper. It has a width of 3 feet, and then it can have a length of however long you can roll it out. If we cut a length of 2.5 feet, what is the perimeter of the paper? So it's 3 feet wide. If we cut a length of 2.5 feet, what is the total perimeter of my piece of paper going to be? Number one. And then I want you to look at this table and complete the perimeter for all of these other side lengths as well, knowing that the width is always going to be 3 feet. Do you guys get what I'm saying here? So we have a piece of paper. It's like always going to be 3 feet wide, and then this length is always going to vary. You need to find the perimeter of each of these side lengths here. X, 3. So you're going to find these 4 perimeters here, 5 perimeters here, and the perimeter when it's 2.5 feet. I want you to take 2 minutes right now to do some calculations. Okay, yes, we can do the first one together first. Let's do that. Okay, so to find the perimeter, what is our formula for finding perimeter? Let's take it one step back. What's the formula for finding perimeter? Good, nice, Gabe. The formula for perimeter is 2L plus 2W, right? And so if we want to calculate this guy here, we know we can, in this box right here, we can write 2L, which, what did we say the length was going to be here? 2 times what? That's our width, Naseem, but yes. So it's going to be our length is 2.5 plus 2 times our length, which Nasim said is going to be 3. Okay. So Abby, we're gonna do one when we move into the table. First one we're gonna do is A. So we're gonna find the perimeter of this guy first, Abby, and then you're gonna go in and do the table afterwards. Okay, does that make sense? So I have 2 times this length, which is 2.5 in this case. What is that gonna be? 2 times 2.5, guess me. Very good, Peyton. It's going to get me 5. And then I need to add to that 2 times 3. Yes, that's going to be your total. 2 times 3 is 6. So it's going to have a total perimeter of 11 centimeters. Or feet, sorry, feet. Okay, so we did this first one together. What I want you to do now is I need you to use this formula to calculate and fill in the rest of this table. I want you to take 2 minutes right now to fill in the rest of this table. If you finish early, I want you to start to take a look at number 3, where you're writing a rule or an equation in function notation. Take 2 minutes right now. Let's get started, guys. I actually gave you 2 minutes and 30. I'm going to erase some of this stuff, guys. So I'm going to try to put some space to show some work. Nice job, Peyton. Oh, Peyton is on a roll. Oh, okay, good. Nice job, Peyton. Kyle, what's that an equation for? Is that the equation in function notation? Okay, good. I was gonna say, yeah. Nice job, Gabe. Very good. I need space for one more. Okay, I'm gonna come up here. Okay, let's do this guy together. Okay, I'm gonna go through these a little bit quicker than I would have. Then yes. Okay, so we have 2 times our length. In this one, our length is 1 plus 2 times our width is always going to be 3. So 2 plus 6 is going to get us a perimeter, of 8 feet. Okay. Now I'm going to plug in my second one here. My length this time is 2. My width is always going to be 3. 2 times 2 is 4, plus 2 times 3 is 6. This one is going to have a perimeter of 10 feet. Nice job, everybody. Now let's take a look at this next one here. This is where it gets a little bit tricky because we have a decimal. 2 times our length, which is this guy right here, 6.3. And then 2 times 3, as our width is always going to be 3. And we would have 6 plus 2, 6.3. For me, should have done this. 6.3 times 2 is 6.3 times 2 is 12.6. And I could have done that subtraction because I knew the final answer to get a total perimeter of 18.6. And then 11, once again, we're going to plug 11 in for our length because that is our variable that we don't know. Our width is always told to us, it's always going to be 3. 6 plus 22 gets me a total perimeter of 28 feet. These labels should be on these numbers in here. It shouldn't just be the numbers. You need a label on there as well. Then our general L, as side length of L, it's 2L plus, there's a couple ways that you could write this. 2 times 3 as a sort of L general term, okay? So then what we had to do was after we found all these perimeters, we had to write it in function notation. We were given the name of the function. So what is the left side of our function note or equation going to be with the function notation? What of what? We were given our variable, we were given our name. What's it going to be? Example, function notation, f of x is equal to 2 plus 3x. What's the left side of our function going to be? We were given the name, letter. We were given the variable of our input. What's it going to be? Very good, Max. That's what I'm looking for. Blank of blank. Not L, because the name of our function here is P. It's going to be P of our variable, our input was given there. P of L is equal to, and now what did you guys write for the right side? There were 4 different ways that you could write this. P of L is equal to, very good, Max. Max said 2L plus 2 times 3. How could I simplify this? How else could I simplify it? Very good, Abby Wasta. Very good, Max. You could simplify it by saying 2L plus 6. Very good. Very good. Nice job, Peyton. You could say 3 squared. You could say 3 squared as well. Very good. You could also expand it and you could say, I'm going to write it in this space right here, L plus 3 plus 3. If we want to think about it that way and expand it out, the last way that we could write it could be 2 times length plus 3. Boom. Does everyone see these 4 ways that we could write this equation? All 4 of these, all 4 of these are correct. It all depends on how does it, like in your mind, how does it sort of stick out, right? Does it expand it out like this, each piece individually, because we're talking about perimeter, we're adding them all together? Does it simplify to 2 L's plus the 2 times your width? Or does it simplify for you in your brain? All of these are correct. All of these are perfect. It's just about how your brain sort of simplifies it. Now, lastly, what does P of 11 represent in this situation? What is its value? P of 11 represents what? Can I have Abby Wasta unmute and tell me what does that mean in the context of the story?
It means that the perimeter is 11 feet.
The perimeter is 11 feet. Where does the 11 in for? It represents our what? In the grand scheme of this number, oh no, that's not what I wanted. This number right here, that variable or number, sometimes we're given a number. What does that represent in the grand scheme of?
Would it be the, oh wait, it'd be the, if it, because right now it's f of x, it'd be f of 11.
Yeah.
So wouldn't it be the perimeter?
Nope.
Or no, it would be attached to the 3.
But what is that? What does the 11 represent? It doesn't represent the perimeter. It represents the, Ian, what does it represent, Ian?
It represents the side length after the paper is cut.
It represents this input. When you're talking about this number that you put inside the parentheses like this, that's our input. And our input is our side length. So Ian, what does this P of 11 represent?
It represents that the side length is 11.
When the side length is 11, what's my perimeter going to be?
The perimeter is going to be 28.
Very good. And my perimeter will be 28 feet. So it's not saying P of 11 does not mean 11 feet that's what it's equal to. No, it's saying when this function's input is 11, what is your output going to be? Because it's in the parentheses always represents this input value. So you're going to take that number and plug it into the equation for your variable, your P of S, right? And you're going to plug 11 in for S, and you're going to solve it to figure out what the perimeter is going to be. Do you see that difference there, Abby?
Yeah.
Okay, good. So it's going to be when the side length is 11, because that's what's in my parentheses here. That's my input. That's my known value. My perimeter, I calculate it, and it's going to be 28 feet. Okay? So now you're going to use this table here on the next slide to create a graph of data points. Of these data points. So I'm going to erase. And we're going to move on to the next slide, and we're going to graph these data points here. 1, 2, 6.3, and 11. Okay, so I need to graph these data points here. Who can help me? I'm going to grab one of my points off the pile. I'm going to go over where, up where. Very good. Nice job. Let's see what that friend is saying. I got too far away. Very good, Peyton. Very good, Gabe. Very good, Kyle. I'm going to grab a point off this pile. I'm going to go over to 1, up to 8. Very good. We can also put one at where? Before we put one at 1/8. We can also put one at 0, 0. Oh, no. Yeah. No. Never mind. We're not gonna do 0, 0. Don't do 0, 0. Miss Shireen got confused. Next one, Peyton says, to get there, we're going to have to go over to up to 10. So I'm going to grab another one off the pile here. Over to 2, up to 10. Okay. Then we need to go over where, up where. For that third point there, friends. I feel like my internet might have gone out. Can you guys? I can't see anybody, so I can't tell. Yes, very good. Oh, thank you, Junior. Over to 6.3, very good. So like we're gonna be very much in the middle of a box here. Up to 18.6. So it's gonna be sort of like in this no man's zone right here. I'm going to erase my ink here, and I'm going to connect these points. So I'm going to start here. And they should, in theory, go through each other. Boom. Okay, so we created a graph of these points, and we can extend it like so. Actually, I don't want to extend it. Leave it at 1. Okay. Thank you, Junior, for that, by the way. Very, very, very good. Nice job, guys. I know that they don't really line up the best. It's because we're not using like a graphing function. But if we look at this line here, or this equation here, what do we notice that's different about that other equation we created before? What do we notice if we compare it? It's not proportional. Very good, Gabe. What else do we notice if we compare this guy here to this guy here? And just keep in mind that, like I said, it's supposed to, they're all supposed to like go through one another like this. That's a little bit better. It's not proportional. What else do we notice that's different about this one and this one? Doesn't go through 0, 0. That means the same thing as it's not proportional. It's a straight line for this one. Yes, Sadie. This time when we connect it, we're going to have a straight line, and it's a linear function because it creates a straight line, as opposed to this guy who sort of had different slopes for each one of these different segments. Nice job, Sadie. Okay, so let me tell you what you're doing for, we're not going to do this today. I'm going to have you jump down to slide number 13. Okay, so your slide number 13 has for you this exit slip that you're going to click on. It's going to take you to Edge Elastic, and you will have the opportunity to complete, I think it's 4 questions. I need you guys to do that now to end off this period today. And then your afternoon work is just these 3 slides here. Once you complete the exit slip, yes, you can submit it, but I would suggest not submitting it until you finish it. So your afternoon work today, all you have to do is on the warm-up slides is 3, 4, and 5. It should probably take you no more than, I would say it really shouldn't take you more than 10 minutes, but like no more than 15 minutes. So you're completing that Edge Elastic. If you did it yesterday, I pushed it back out because you had to, because I didn't want you to complete it before we finished the lesson. So there is that. People are working on it. Junior, John, get in, please. Gabe is working. Please try to get into that. Sadie, Kyle. Cindy hasn't started it yet. Please get into that. Adam, please get in, get started. Cameron, Ian, Tyler, please get in and get started. Everybody else is in and started. Awesome. Thanks, guys. Don't leave yet. Don't leave. And listen, when you submit it, it might say like, this is incorrect. It might give you a score. I don't know how it's set. I have to go through and I have to look at them. So none of them are going to, I mean, like if it says you got it correct, then like good, but like most of the time I have to go through and like hand correct it. So just try your best. So afternoon work is the rest of that warm-up slideshow. John, you still haven't started it. Please get in there, dude. Nice job, Max. Nice job. Kyle, Adam is in, Cameron is in. Ian, I don't see you in there yet, dude. Get in, please. Tyler, I don't see you in yet. Please get in. Enter. I'm refreshing it. Oh, perfect. Thanks, Ian. If it's loading, let me know. Because then I don't want to be like annoying
Good
about
morning. We would just like to wish Donna a happy birthday. Check your mailbox.
it. Check your mailbox. I love it. Very nice job. If you don't get a chance to finish this, remember that you will have, so it'll save your responses. So if you come back into it this afternoon to finish it, please don't be like, oh no, I'm gonna have to do all of it again. No, it will save your responses. So if this doesn't get finished, people can start to, if you finished, you can start to move out to science. Actually, everybody can start to move out to science. And if you didn't finish this CFA, it needs to be completed this afternoon. So you're going to complete the CFA, and then you're going to complete the 3 slides that are attached to the warm-up slide for this morning. Is everyone clear on what you need to do for afternoon work today? Oh, no. Oh. Perfect. Thank you, Naseem. So if you guys, if you want to jump out, you guys can start to head to science. I will see you all tomorrow. Please bring the heat. We're going to be moving into a new lesson. Questions, let me know. Send me emails. Bye. Bye, Kyle Kelly. Hey, Gabe. I didn't mean to do that creepy smile. Sorry, dude. So let's see. I have it open right here, Gabe. So let's see. Ooh, nice job, Gabe. Right now I have to go through and I have to check the last one. Now, oh no, it's fine. Take your time. You're fine, Gabe. Right now you have a 75, but that means I still have to go back and check the last question. So I sort of have a feeling that you did very well. And I don't even know why I'm saying a sort of have a feeling. I mean, I know you did very well. Okay. I'll see you. Have a good rest of your day, Gabe.